This is 3.6 Combining Functions Day 1. We are going to be adding, subtracting, multiplying, and dividing functions. If we have functions f and g, we will add, subtract, multiply, and divide them. And I'm going to show examples where we have these different things going on and how the domain is affected. When we add two functions together, showing the notation of f plus g in parentheses of x, that's the same as taking the function of x and adding it to the function of g. And the domain is just taking the combination, the intersection of the two domains. And so let's say, for example, we have two domains saying -3 to infinity. And we also have -infinity to infinity. Well, the intersection of these would state the overlapping parts of the domain. So the overlapping domain, the intersection, would be -3 to infinity. So that's what we mean by the intersection. When we subtract and we have f minus g of x, you are taking the two functions and subtracting them. So in all reality, these two right here are like combining like terms. When we have to multiply, we would have f times g of x, which is taking the two functions and multiplying them together. You may have to FOIL, distribute, whatever, but you're multiplying the two together. So again, the domain on all of these so far is the intersection of the two, of each of these separate. When you divide f over g of x, you are dividing the two functions. A lot of times you really can't do much in terms of simplifying, but if you can, you're looking to factor something out and cancel. But the domain here is going to be not only the intersection of the two domains, but also you are going to have to realize that because of g being in the denominator, whatever that domain is, you cannot have equal to 0. Let's look at this example. It says, find f plus g, f minus g, f times g, and f divided by g, and their domains. If f of g is x cubed plus 2x squared, and g of x is 3x squared minus 1, if we have to add these together, we're going to take x cubed plus 2x squared plus 3x squared minus 1. And we look for combining like terms. X cubed, there's nothing. 2x squared plus 3x squared is 5x squared, and then minus 1. So f plus g of x is equal to x cubed plus 5x squared minus 1. For f minus g, we are going to have x cubed plus 2x squared minus, now because we're subtracting an expression, we have to make sure we put the expression in parentheses. That means we will distribute, and we will get x cubed plus 2x squared minus 3x squared minus 1. combining like terms, we have 2x squared minus 3x squared, which is negative x squared. And we get f minus g of x to be equal to x cubed minus x squared minus 1. F times g, we will take x cubed plus 2x squared in parentheses times the 3x squared minus 1. We will FOIL. We'll take x cubed times 3x squared, which is going to be 3x to the 5th. X cubed times negative 1 is negative 1x to the 3rd. 2x squared times 3x squared is going to be 6x to the 4th. And 2x squared times negative 1 is negative 2x squared. Now I look for anything to combine as far as like terms. I have nothing here. I'm going to write this in order though. So f g of x is going to equal 3x to the 5th plus 6x to the 4th minus x to the 3rd minus 2x squared. And f divided by g is going to be x cubed plus 2x squared over 3x squared minus 1. Now I would look to see if I could factor. I could factor x squared out of the numerator, and that will give me x plus 2. But the denominator cannot be squared. So factoring does not allow me to simplify anything. And so f over g of x oh my. Okay, f over g of x is just simply x cubed plus 2x squared over 3x squared minus 1. All right, now let's look at the domain of each of these. Now remember, domain is, we have to start with the idea that we have all real numbers. Unless we have the restrictions where we have 1 over some type of expression. I'm going to put a capital A. If we have the square root of some kind of expression, and we have 1 over the square root of some kind of an expression. So when I look at f plus g of x, I do not have a fraction and I do not have a radical. So my domain here is all real numbers. So I could put all real numbers, which is this r, or as interval notation, I would go from negative infinity to positive infinity. When I look at f minus g, again, x cubed minus x squared minus 1, I do not have a fraction and I do not have a radical. So again, my domain is all real numbers. And so I would put one of these statements. For f times g, I still don't have a fraction or a radical, so my domain is still all real numbers. But when I get to f over g, I have a fraction. So my domain is restricted by the fact that I have a variable in the denominator, and I need to find out when is 3x squared minus 1 not equal to 0. or actually when it is equal to 0, so that I can say it cannot equal 0. So I'm going to add 1. I get 3x squared cannot equal 1. I divide by 3, and I know that x squared cannot equal 1/3. And then I take the square root, and I know that x cannot equal the positive and negative value of the square root of 1/3. And what I really need to do is, because I have a square root of a fraction, I need to rationalize the denominator. So right now I have the square root of 1/3. That is the square root of 1 over the square root of 3. The square root of 1 is just 1. So I have 1 over the square root of 3. To rationalize this, I need to multiply the square root of 3 over the square root of 3, which would give me the square root of 3 over 3. So x cannot equal the positive and negative value of the square root of 3 over 3. So my domain is x such that x cannot equal the positive and negative value of square root of 3 over 3. So I can write it that way. And then as far as interval notation goes, I go from negative infinity to the negative value of the square root of 3 over 3. And since I can't equal the actual number, I'm going to put parentheses and then union. And I can't just go from negative square root of 3 all the way to infinity, because I have the positive square root of 3 over 3 that I cannot be equal to. So this, I'm going to say from square root of 3 over 3, negative square root of 3 over 3, to positive square root of 3 over 3. And then I can write another notation going from the positive square root of 3 over 3 to infinity. And that's my interval notation for this domain. Kind of crazy, but when you have multiple numbers that you cannot equal, you're going to have multiple unions of the domain. I do not need to graph this, so I don't need that graph that was sitting there, but I just needed to add, subtract, multiply, and divide, and then express the domains. Now, let's look at this example where I need to find the domain of g of x. And g of x is the square root of x plus 1 minus 1 over x. Well, I have, basically, we are subtracting two different types of functions within g of x. And what I need to do is find the intersection of each of the domains. So I have the square root of x plus 1, and I have 1 over x. As far as the domain for the square root of x plus 1, I have to set x plus 1 to be greater than or equal to 0. And I always solve by subtracting 1, and I would get x is greater than or equal to negative 1. For the fraction, I cannot have 0 in the denominator, so x cannot equal 0. So if I'm saying that x can be greater than or equal to negative 1, think about this on a number line. Here's 0, here's negative 1. Technically, if I was thinking about the square root of x plus 1, I would draw a solid dot and go to the right with an arrow. But it cannot equal 0, so that means I have to have an open dot here at 0. So if I'm going to draw an arrow going to the right from my negative 1, it's going to be stopped at 0. And then I can continue on after that. So what that means is, as far as interval notation goes, I am going to go from negative 1 to 0 with a parenthesis at 0, union, and then I'm going to go from 0 to infinity. And I could say x such that x cannot equal, oops, I'm sorry. That's actually going to be written differently. And I would say -1 is less than or equal to x, which is less than 0. And then I'm going to intersect that with x has to be greater than 0. So that would be my domain. And then finally, we have functions where we have to apply addition, subtraction, or whatever to a graph. And we have graphical addition. And what we want to do is we want to pick key points on each graph and add the y values together. So if I'm referring to the function of f, and f is the bottom graph, the linear function here, and g is the graph up above, and I'm referring to f when I say x equals 0 and the y value of that point, and then I'm going to add it to g. So if I look at f at x equals 0, my y value is 0. Well, then I look at the g function where y equals 1, and I'm going to add 0. And so what I'm going to do is I'm going to take that 1 and add 0 to it, meaning I get 1. If I look at the f function at x equals 1, I'm at 1/2. So I'm going to go up to the g function, which is at 2, and I'm going to add 1/2. That means I need a point at 1 and 2.5. So 2.5. At x equals 2, I have y equals 1 for my f function. So I'm going to add 1 to my g. Well, my g is at 1, 2, 3. If I add 1, I'm at 4. So I'm going to plot a point at 2, 4. So I'm going to continue doing that. So if I go along, I have 1.5. So I go up here. Looks like I'm at 3.5. So if I add the 1.5 from the f function, I go up 1/2 plus the 1. I'm at 5. Going to the f function, when I have x equals 4, I'm at 2. So I go up to the g function, and I have to increase by 2 units. So up 1, 2. When I look at the f function, I'm going to go up to the next whole number, over to 1, 2, 3, 4, 5, 6. I'm at 3 units up. So I'm going to go to this g function, which looks to be around 1/2, and I'm going to go up 3 units. 1, 2, 3. And then finally at the end here, I'm up 4 units. So I'm going to go up to the g function and add 4 units. 1, 2, 3, 4. And then I can draw my line through these points. And I'll do the best I can. And there we go. So the red is the f plus g. So if I had to subtract, I would do the same thing and say, like, okay, at f I'm at 2. I go up here and I have to subtract 2, 1, 2. I would just go down 2 units. Okay, but you're affecting the y values and either adding them or subtracting them or whatever you need to do. Okay, and that's it for 3.5. No, I'm sorry, 3.6 day 1.